let's talk about the electromagnetic spectrum. Now, if we look at the different waves that are on the electromagnetic spectrum, what we're going to do is we're going to start with the type of wave that has the greatest wavelength. So that would be our radio waves. Now, the big misconception in the electromagnetic spectrum is that most of these waves are visible. Not true. It's the exact opposite. Specifically visible as in like visible light. Most people think most of the electromagnetic spectrum is Roy G. Biv, the visible light colors that we see. That's only a tiny part of it. So, radio waves have your largest wavelength. Now, if you remember, your wavelength is one complete wave, okay? Distance from here to here. Now, you can also measure that crest to crest, trough to trough, okay? A couple different ways to measure your wavelength. Now, your second type of wave is your microwave. Our wavelength, as we're going from radio to micro, gets a little bit smaller. So radio, as we said before, is the largest wavelength. Our next one get this moving right here, is infrared. Now, most people are not familiar with infrared, but the best example I can give you is, if you've ever seen those Predator movies, the Predator uses infrared waves to see. That's how, if you saw the original Predator, he was able to see all the soldiers, even though they were wearing camouflage and hiding in the brush in the jungle. The Predator could still see because he used infrared wave technology to see his opponents. He could see the heat, or the heat energy, if you will, coming off in the soldiers or different animals. Wavelength getting a little bit smaller from microwave to infrared. Your next one is visible light. This is basically the middle area, if you will, or halfway point of the electromagnetic spectrum. Now, you're familiar with your color scheme, which is Roy G. Biv. That would be red, orange, yellow, green, blue, and just to make this easy on myself, indigo, violet. That same order of the visible light goes right here, and it increases in strength and then shortens in wavelength. So as we go from radio to micro to infrared to visible light, the energy is getting higher or getting larger. The wavelength, as we go across the electromagnetic spectrum, is getting smaller. So, if we put this into terms here, okay, wavelength getting smaller and energy's getting higher or larger. Okay. Our next, I'll move this out of the way. Our next wave is, oops, make that a little bigger for y'all. Ultraviolet rays. Now, you're probably familiar with this, UV for short. Those are the waves that people talk about that you need to be careful when you're out, especially in the summer and the spring. Those rays come from the sun. You need to wear proper sunscreen to protect yourself from those UV rays, okay? Next one, everybody's probably experienced using some of these before. If you've ever had a X-ray done on your body because you've had a broken bone or maybe a fracture, you've had what's known as an X-ray. Now, what actually happens there is the photo that they give you, they call that the film. That's just the film. The X-rays are used to make that picture of your broken bone or your fractured bone or something like that. And once again, wavelength is getting smaller. Energy is increasing. Our next one and last one is gamma rays. These have the smallest wavelength, most energy. A lot of people associate the gamma rays. They can remember, if you're into the Marvel Cinematic Universe, according to their storyline, gamma rays created the Incredible Hulk. So that's where a lot of people have heard that from. One other thing I want to show you and mention about the electromagnetic spectrum is as you go from radio to micro to infrared to visible light, and as you continue, UV, X-ray, gamma. As you go from one side of the spectrum to the other, okay, we mentioned one, okay, increase in energy. Change pins here for you. Increase in energy. Okay, going from radio all the way. So Gamma has the most energy. Okay. And those are supposed to be arrows. Okay. Your wavelength, going from radio to gamma, wavelength gets smaller. So think about this. The smaller the wavelength on the electromagnetic spectrum, the more energy you have. And then lastly, just thinking about wavelength, okay? If you have a certain amount of waves measured in that certain amount of time, you have what's known as a frequency. So your frequency, okay, which these two go hand in hand, because the smaller your wavelength is, then the more waves you're going to have, which creates a higher frequency. So it will look something like this. If your wave going from radio to gamma would go something like this, and as it gets up to gamma, it would just kind of shorten. So you're actually shortening the wavelength and increasing the frequency. So as your wavelength goes down or decreases, your energy, okay, increases, and your frequency increases. Now, there's a lot of other things we could talk about as it relates to the different waves in the electromagnetic spectrum. We could talk about some waves have the ability to penetrate Earth's atmosphere. That would be specifically visible light. Change colors here on y'all, sorry. Visible light and radio waves can both penetrate Earth's atmosphere, okay? Now, temperature-wise, if you go from radio all the way over to gamma, temperature increases. And you would measure the temperature of these waves in Kelvin, because you're dealing with high-level temperatures. So this is a little summary of the characteristics of things that you can find on the electromagnetic spectrum and the different wavelength, energy, and frequencies of all of them. I'm going to give you in closing two things to look at for reference purposes. One, this is just a printed out chart from the University of, Waikato. There's all kinds of electromagnetic spectrum illustrations out there. My advice is to draw one like I just did and talk yourself through all the characteristics. And that way you have made your own. If you notice here, this one goes right to left. Left to right. A lot of them go right to left. So my advice to you, whenever you're dealing with the electromagnetic spectrum, please look at what type of waves it's starting at so you can go through and make sure you have them all in the correct order. It is not uncommon for them to start with gamma. So as you go from gamma to radio, okay, the wavelength is actually increasing, and then your energy level is going down, and so is your frequency. The flip side of that would be, as you're going from gamma to radio, instead of going Roy G. Biv, you would go backwards. So you would start with violet, and then work your way down to red as you go back to infrared, micro, and radio, okay? This particular illustration here, you can see the illustration of the wavelength as it is very small, gets a little bit bigger, a little bit bigger, 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 and bigger. And here the frequency is going down. And again, with that, the energy level is going down as well. So if you're going again from gamma to radio. And one more I want to show you is this one right here. This one is interesting because it gives you some precise measurements of the temperature and the frequency, which is measured in hertz, as it relates to each type of wave. And it's got the actual wavelengths here measured in meters in exponents. Again, just illustration there of the wave frequency and wavelength. And then here it compares the size of the wave as it relates to things that you can associate with. But again, two really good electromagnetic table illustrations for information purposes. Again, my advice to you is as you go through this, just draw it out. That way you have your own and you can reference your own as you familiarize yourself with it. Here's one that was drawn up before. And again, this one was done from radio to gamma. And just putting, like we talked about a minute ago, wavelength, frequency, and energy as it relates to, if you notice, gamma's on the left and radio's on the right. Like I said, just keep that in mind as you start. And I personally like to go from radio to gamma, smallest to largest, just makes things easy. Again, whatever your preference is, draw that chart and familiarize yourself with all the different characteristics. Thanks for watching. We'll see you soon. Bye-bye.